So as we've seen, there are different syndromes that can occur when people have different XY chromosomes, or they have SRY gene that is in the X chromosome where it's not supposed to be, or the SRY from the Y chromosome doesn't work. So that's people who have things that are happening at the chromosomal level. But then there's a number of other things that can alter sex determination. Androgen insensitivity syndrome is when people who are XY, so their biological sex is male, but their tissues are insensitive to androgen. So insensitive to the male hormones. And so as a result, their tissues don't respond to androgens. They identify as women, even though they have the sex characteristics or the genetics or the biological sex of being a man. Then there's these two are the ones that are probably the most important when we talk about sport. So there's the congenital adrenal hyperplasia, and this is congenital means from birth, adrenal, so that's on top of your kidneys, and on top of your kidneys you have an increase in the number of cells there. And what this is biological sex, females, so they have two X chromosomes, but because they've got this hyperplasia where there's this bigger adrenal tissue, they have low cortisol levels and they have abnormally high testosterone levels. And so they develop muscle mass and body size much more typical of a man. Because again, testosterone, especially during puberty, has this ability to increase body size and muscle mass. And so this is going to take somebody who is genetically a woman, has the external genitalia of a woman, but give them the muscle mass, strength, and power more typical of a man. And then we have the 5-alpha reductase deficiency. And this is individuals whose biological sex is male. They have male gonads, but they have sometimes got female genitalia. And what that means is the external genitalia are that of a woman, but the internal sex hormones or the sex structures are that of a male. And this can reverse at puberty. So it can switch, the individual can switch from male to female, or from female to male, I should say. But some remain externally female and internally male. And again, gender role here varies between individuals. So some of them identify as women, some of them identify as men, and that's the gender component of it. But their biological sex is male. And so again, these two things can result in somebody whose biological sex is male, but has an external genitalia of a female. And as a result, they can have the external trappings of being a female, but they might be able to compete and get a bit of potentially an advantage if testosterone is going to give us an advantage. All right, so what does testosterone do? And testosterone, when there's a couple of things that we know it does. And the first and probably the most important thing that it can do is, at least at a performance level, is it increases the amount of the oxygen carrying red blood cells. So females have lower red blood cell mass than males. Some of that is due to testosterone. It is, it's also due to shedding of red blood cells on a periodic basis in women. That doesn't happen in men, but there is this effect of testosterone also where you're increasing red blood cells. You increase bone density. And then if you are in a transition like in puberty, you increase muscle mass. And it's really during puberty where testosterone has the biggest effect on muscle mass because it's setting down these limits for how much muscle you're going to be able to carry. Okay? So it can have all of these. This is why testosterone is a popular performance-enhancing drug in runners, mostly because of this red blood cell carrying capacity. They don't want to increase muscle mass. They don't even really want to increase bone density. They just want to be able to carry more oxygen because oxygen is going to be relatively important for their running performance. Okay? But now you've got this thing we talked about in the Big Bang of body types. If you have a extra mass, that actually increases the cost of running. Yes, it's going to be offset a little bit by oxygen carrying capacity, but it's not enough. So really, there's this sweet spot of where this would be beneficial. You have more muscle mass, so therefore you have to carry more muscle. Therefore, the cost of transport or running is higher. But there are some sporting events that are short enough where having the extra muscle mass isn't as detrimental. And there's really a sweet spot here, and the sweet spot seems to be at the 800-meter level. And so this is Caster Semenya, who's a very famous athlete. She competes for South Africa here. And you can see her and some other athletes here in the women's 800 meters who are known to have high testosterone levels. They are known to be female. They have the external genitalia of female. They have grown up. They see themselves as female, but they do have higher testosterone levels than others within the race. And so now this is the sweet spot, because if you go out to 1500 meters, Caster Semenya is very beatable. But at 800 meters, she doesn't seem to be beatable when she's not taking anti-androgens. So now this is the real conundrum here, because what happens, what determines whether she should compete as a male or compete as a female? And that's really one of the biggest questions in sport right now, is whether she should be competing in this category of women's athletics, or whether she should take, or if she wants to compete in women's athletics, does she have to regulate her testosterone level? But the reality is that she is a woman, that she just has high levels of testosterone, and that's given her an advantage in this particular race. And so all of the other women who are competing also have small little mutations that have made them very, very good athletes. So where does it cross the line from being something that's advantageous for performance to being something that's cheating? And that's really the hardest part for the arbitrators of sport right now.